Don Larson speaking. We're ready to get started with our webinar today on S1000D compliant illustrations. But before we get started, let me cover the housekeeping rules for the webinar. All attendees will be muted for the duration of the webinar. If you should have any technical difficulties or issues, use the little chat box in the control panel to notify us, and we'll address that. We have some informational handouts that are in the relevant to our webinar today that you can drag and drop off the control panel to your desktop. So we invite you to do that. If you should have any questions during the webinar, feel free to post them at any time. Don't worry about interrupting us, as we'll collect all those questions, and then at the end of the webinar we'll address those, and we'll make sure that all those get answered. If not, we'll follow up with an email. For those of you who are not familiar with Larson Software, we're based in Houston, Texas. We're have been graphics technology experts for over 30 years, developing powerful, innovative graphics software, 2D graphics, 2D and 3D graphics software and toolkits based on open standards. We've promoted CGM from the very beginning. Originally, we had a free viewer for CGMs, but now we've recently replaced that with a downloadable one that you can purchase on our web store. We're the developer of the first HTML CGM viewer to eliminate the need for plugins. We're a member of the CGM Open Foundation that maintains the CGM standard, and Larson Software technology simplifies the graphic workflow for technical publication professionals. So with that all said, let me turn it over to David Manick for the main part of our presentation, and I'll be joining you after for the Q&A session.
Thank you, Don. Good morning, good afternoon, good evening to everybody. Thanks for joining us today. This is our last webinar of 2022, and we thought we'd do our S1000D compliant illustrations webinar. We do this annually, so obviously the 2022 edition, and hope you enjoy the content we've got for you today. We've got quite a lot of information to put over. We've got some demos, and the demos are really around the concepts of the spec and the requirements of the spec, rather than our software. So, but we, as a byproduct, we are showing some software as well. So, the agenda, as you see there, we're going to have a quick intro. I'm not going to go too much into the spec from any other than graphic requirements really today. Some quick reports on 2022, and then the guidelines for 2D, and then we'll discuss 3D, and then, as Don mentioned, we'll have some Q&A time at the end if you want to submit questions. So please do that as we go along, and then we can just go through them at the end of the webinar. So probably many of you here are familiar with the spec. It's been around since the 1980s, more predominantly in Europe than probably North America. The main concept was to hold information in a modular form. Therefore, we have data modules. And the objective really was a more flexible method of managing technical documentation. So rather than a really long book, which you would then have to revise and then publish again, you could just do it via a data module, like a smaller piece of information. So I would say today S1000D is really widely adopted globally. We have a lot of customers all around the world now using the spec, and graphics is really a fundamental part of the spec itself. It's documented, and the requirements for graphics are all there for you, and we'll go through some of those today. So hopefully it gives you a good introduction to the graphics part or illustration part of the specification. You can download the spec from s1000d.org. It is free. You just need to register there, and you can download the spec. I just discovered yesterday that the S1000D User Forum is already scheduled for next year in the US, 2023, in Florida. So that's already there on the books. You can't register as yet, but if you visit the site, you'll see the venue, and you might want to put that in your calendar. So this year we did have a user forum, and it was actually in conjunction with the ATA e-business forum. So we had kind of two sets of people attending, and that was a few months ago, located in Seattle, USA. It was actually located right next to the Boeing plant there in the Seattle area. So we had both kind of aerospace defense, but also commercial airlines and manufacturers. So a really good audience we found at that event. We were exhibitors, so we actually had a booth there, and we had a speaking slot, and our topic was 3D graphics, which there was a lot of interest in. For your information, the event was really well attended. In fact, it was sold out, so they couldn't actually handle any more people in that particular venue. And what we did discover is a big interest in graphics, mainly a kind of SVG on the 2D side, and 3D, really the creation and display of 3D graphics and how that could be done within the specification. And we also interest from other vendors as well, who create CSDBs and IETMs and so forth, who were mainly interested in the 3D side. The other thing that's happened this year is that the S1000D Graphics and Multimedia Working Group has kind of reformed. And we've kind of missed this because from a graphics point of view, there's not really been a lot going on. The spec really hasn't changed in that respect. So I think it was important that group was reformed. And the objective really is to talk about these graphic standards going forward. And the first task that's been worked on is really the SVG file format. This has been kind of driven by industry, who really want some guidelines how to write SVGs and how to use them within their publications. So that has begun. We are participating in that group mainly in an observational role, but we provide guidance where we can. From a history point of view, Don was part of the team that worked on the CGM S1000D profiles. So, vendors or software developers have worked on the spec before, so that is not unusual. The current status is that an SVG white paper has been submitted to various committees who are currently reviewing it. So once that's gone through, which hopefully it will do early next year, then we'll begin to develop the SVG profile and also documentation for the spec itself. I think the target is that it will be included in the next issue of the specification. That cannot be guaranteed, but that would be the target. So that's a kind of brief report on where we're up to with the spec and how it's being developed with SVG. So if you're not aware, the spec is at issue 5, and it hasn't really changed since our last event, but I think it's good to go over these things because we had these reports to make, and you can now see perhaps we're going to get some movement in the future. So if you're interested in the spec, as I said, you can download it, and the chapters you can see here are the ones really that you need to look at with respect to graphics, and that's what we'll cover today. So there's a lot of 2D guidelines for illustration, rules, so forth. There's parts that are on the 2D file formats, mainly CGM. There's no real mention of SVG at the moment. There are quite a lot of 3D guidelines, which we'll discuss as we go along. So there's a lot of guidance there, but not very much low-level stuff. It's all quite high level. And then we'll talk about 3D file formats where there isn't a format at the moment that's been specified by the spec as it is. There's no 3D file format. So we'll discuss that as well. So many of you are aware how you create your illustrations. But this is where I feel we're up to, is that that we have various legacy illustrations which done previously, and then we have new illustrations that would usually be created perhaps today from CAD data. And then these could be 2D illustrations with interactivity, and then they could also be 3D using different 3D file formats. Once they're created, they're going to finish up in your CSDB, where they're going to be managed, then output usually to an IETM. And at this point, you're going to need either a 2D viewer or a 3D viewer that can actually display those graphics. So, and that applies to both legacy and new illustrations. So they're all going to go through the same kind of process and end up being displayed to the end user here, usually by some viewing technology. So the 2D illustration guidelines in S1000D are all documented in this particular chapter, 3921. So they're really well written. There's a lot of illustrations, examples as well that you can look at. So I think it's a really good part of the spec. A lot of thought has gone into it. And I think this will probably not change. It'd be more that the introduction of SVG as a file format will be the main change in the next issue. So as I mentioned before, we have new illustrations and legacy illustrations, but the main use of illustrations within the spec is to communicate where text can't really do that. So they need to be simple and clear and economical, and also visually enhance the information, so they're not there just for the sake of it. They should really be prepared in accordance with the text. So if there's a procedure, then obviously the illustration should match that procedure. And as I said earlier on, the source data could be new or legacy, depending on your project probably. So the main illustration appearance would be isometric. Kind of old legacy might be perspective, but the guidelines for new illustrations would be to use isometric. There are certain line weights that they recommend, line styles, annotations, symbols. But obviously this is impossible if you've already created them many years ago. But again, these guidelines, you could comply to them, or they're more guidance than compliance. They won't fail anything. It's mainly the file formats that need to be validated. Within the spec, there are some business rules decision points, so BRDP, that you can have with illustrations or graphics. So do you use color or not? There is color used. A lot of commercial airlines use color within their illustrations. So, but that is a business rules decision point within the specification that you can use or not use. So there's various symbols that are outlined in the spec. So again, these are pretty standard ones you might be using already. So again, good to follow these so we get a consistency with the specification for actually labeling things forward, up and down, so forth. And the use of color, I mentioned this is probably mainly used in commercial aircraft, is they use a lot of color to show various states of the illustration, or if it's a part, so or it's the assembly, so the main assembly, things attached to it would be yellow, then light blue for the parts of the illustration, and then gray parts that could be on subsequent illustrations. And all these colors, we'll see in a second, are in a palette. So this is the recommended palette of S1000D. So these are the colors really you should be using to comply to the spec. So at this point, I'm going to go into a bit of a demo. So we created this particular template. So this is in our VisX Edit software, which 2D illustration. So what we did is create a template to show probably the things that you might need if you're going to start illustrations from new. So obviously we've got an isometric illustration here. So and we have a drawing area, and we also have the colors and some descriptions of the pen weights, so forth. We've also got hotspots on here as well that I just highlight with the one at the top, and we can see the hotspots down this side as well. We'll talk about hotspots a bit more in a future demo. We also created a small library here of those symbols, so we can drag and drop from the library onto the illustration. So once you have a library created, then within here you could easily reuse those within the project or within the illustration. And it could be parts. It might not just be arrows and symbols. It could be actually parts that you want to bring in here, like a bearing or whatever. So the other thing here, we've actually in this template created all the line styles that you might need, and all the fills or the palette that we have down here. So what we've tried to do with the illustration software we have is try and make it easy as possible to get started with a specification. And this is the template, so you could just reuse this within your own project if you wanted to. So if I got a blank piece of paper, which is rare nowadays, if I was drawing from spec, from scratch, then you can see that I can draw to the grid. So let me just delete that. Let's start a bit higher. And it's snapping to the grid as we go along. So we've got our isometric, and then if we've got an ellipse on here, we're automatically creating that ellipse to the grid. So kind of common things you would be drawing from scratch, you can easily do that within the software here, or we could bring in CAD data and reuse that as well. And also things like annotations, like callouts. If we were creating callouts, then we have a tool that would already start to create the callout along with the hotspot as well. So these would be hotspots. So with our illustration tool, we're trying to make it as S1000D compliant out of the box as possible. Okay, let's go back to the slide. So 2D file formats. Yeah, the main two being used, and I mentioned two being used, is that even though SVG is not in the spec, it's still being used. So, and that's really been the big driver to get it into the specification. So with CGM, it's very well documented. It's within the chapter 732, so you can find out all you want to know about CGM and hotspots and so forth in this particular chapter. So as I said, CGM is still the only 2D graphics format documented, and SVG is being recommended, and I would hope to see that hopefully next year within the spec. They will create a profile similar to CGM, so then we'll have something that we could use interoperably. That's the target or the objective. But with CGM, we've got 4 versions. Only version 4 can contain hotspot information, so that's really generally the only format you see now. CGM's still good. Obviously, our company, or Don's company, was founded on CGM, so it's still a really relevant format. There's a lot of legacy data in it. It's a multi-purpose format capable of editing and display, so don't kind of think you have to throw it away. And the CGM profile provides that interoperability and validation opportunities that hopefully SVG will do in the future. So version 4 was adopted really because of hotspots, and these are taken care of with something called an application structure. So really metadata that you can add to the illustration so you can interact with it in some way. So the metadata would usually be in the CGM, and then it can interact with the XML to actually create interactivity between the two. And the spec provides guidance on how to do this. But SVG is a bit different, and because people are using it, we've done a lot of work on that particular format over the past probably 3 to 4 years. It's a specification, it's open, which is good. It's XML encoded, so it's a text-based format. It has governance, it has working groups. And the big thing was that why the S1000D community started to use it really was it was native support, its native support in web browsers, so there was no plugin required, where a lot CGM at this time really needed a plugin. So it's supported in all the major browsers. But the spec is really big, SVG. There's a full version and then there's a tiny version, which is just a subset of the full version, which is really designed to perhaps go onto phones and tablets. But there's some benefits of using SVG, and a lot of them are kind of because they match or map over to CGM. So one of the big differences is always it has native support for HTML5, so you don't need that plugin. But it does support metadata, so you can have hotspots and interactivity. You can embed raster images that retain their ability to be edited. And it also has the ability to have 2D animation, and it can also be data-driven from a spreadsheet or a database. I think the last two will not be covered within the spec, but SVG is capable of doing these things. The caveat, the main kind of warning I would give is, and that still probably applies at the moment, is that SVG was designed as a display format, not really as a data exchange format. And that's where we've been working really hard to make it interoperable, at least with our own software and perhaps with other software like Illustrator and so forth. But the schema they have for the XML is really, it's just the whole spec. So that's not really very useful for us because not everything we need in there. So what we did is we created our own profile really to help us within our own software environment to interchange SVG files. So we called it Tech SVG. We published it publicly, so it's not private, it's not proprietary. And really, it's kind of a mix between the full SVG version and the tiny one to get all the elements we need from a technical illustration standpoint, such as hotspots, line styles, fonts. And we have submitted this to the working group so they can use this perhaps as a basis for the profile in the future. So interactivity is a big part of the spec as well. So hotspots. So in CGM, there's a definition of a hotspot and how you create it. And that's what's lacking really in SVG, that there isn't that information. So, and that's what we've tried to do is write hotspots in SVG in a particularly standard way. But in CGM, then it's pretty straightforward. So, but the hotspot information it really resides in 4 different files. It resides in the data module itself because you need to kind of put the CGM or link to the CGM in there in some way, even just as to display it, not interact with hotspots. And then if you've got the illustration with hotspot information, then you need metadata to be able to link the two together. So if you want interactivity and want to display the illustration, they're essential. The 2 options are if if you want to put metadata into a separate file, you have something called the XML companion file, XCF, and then you have the ICN, which is fairly new, which is an XML file, which can also contain metadata. They're optional, so you don't need to use them. Then they won't nothing. It will still work without them, but they're interesting options, and we'll discuss those later on in the presentation. So as I said, you need a data module. You need the data for that CGM inserted inside that data module. And if there's hotspot information, you usually have a unique ID within the data module as well, so you could do the linking to the CGM file. The XCF is a companion file, and the reason you might use that is you've got kind of more richer metadata that when you use with a graphic that can't be saved within the CGM file itself. So we've seen these mainly used within commercial aircraft projects where they might put translations in to actually enable the illustration to be seen in multiple languages. And then the final one is the IMF file. I haven't really seen a project using this yet. It was new in issue 4.2, but the IMF file is closer to the structure of a data module. So it not only could contain metadata for the hotspots, but it could also contain management data of the actual CGM itself. So you could actually have like a security level to it and a work number to it. So, but I haven't seen that implemented anywhere as yet in anybody's software. So just going back, a visual way of looking at this is we have the data module on the left here. This would be the fragment in the XML. So you have the illustration called out at the top here, and then if there was hotspot information, that would be inserted below that, and then the link really is the ID. So the ID within the CGM file matches the ID within the XML. So that would then forge that link between the two, so then you could interact between the text and the graphic. In the case of the XCF file, it's contained in an XML file, and the XCF file is documented within the spec. There is a chapter on it. So the same applies here, but this time the file is actually a separate file, but then would still link to the data module. And then finally, the IMF file. Again, that data is pretty much the same. But this time you might see like an ID and status section up at the top here. So this is where we would kind of manage the graphic to give it security clearances and like in work numbers. So you could, in theory, manage it within a CSDB using the IMF file. And again, that is documented in the specification in chapter 3927. So, yeah, I think with the IMF and XCF, there will be specific times you want to use that. And the most common way at the moment that I see anyway is just the metadata within the CGM file itself. Okay, so if I just go another demo just to quickly show you about hotspotting and interactive graphics. So let's just go back to Vizet's edit. So with this particular graphic here, I've annotated this using our annotation tool, and you can see on the left here that we have the hotspot information. So if I right click on it and modify, you'll see that we have that ID I was speaking about, which is unique. Then the name is the name of the hotspot itself, in this case, number 7. And then we could you can have a screen tip for it. And you could also, if it had an external link, you could put an external link in here as well. So this is all to the spec, so all these things can be included in the hotspot information. What I can do here is just click and I can see that I should be able to see the hotspots. Oh, sorry. So we have the hotspots that we created on this particular illustration, and hopefully this will work. I might be able to view this in a browser. It's gone to my other screen. Let me just drag it back over. So there, I'm just previewing it, and I should see that tooltip. So we put this in just to help the illustrator preview his work, preview the hotspots, just to test them out and so forth. As obviously, this is not going to be printed, so it's going to be an electronic delivery. And the kind of final outcome is if I go to here, now I'm seeing the illustration within a viewing environment. So now I'm in the web browser, in this case Chrome, and again I see the different tooltips. So this is the viewer, not the illustration tool. And with this one, we've actually linked it to an XCF file which contains different translations for the tooltips. So as you move over, so this is an example how you could use the XCF file. So if I go back, we got Spanish. So this is just happening because I'm changing the requirement within the viewer to display those. So that's an example of the XCF. And going one step further, if you had an illustrated parts catalog, then we could see that we could highlight this where the linking would come in, where we can link to the text and the graphic. So as we move around, the hotspot would highlight that particular row on the illustrated parts data. And in theory, this should work in reverse as well, because once we built that link, we could click on, say, number 3, and it would highlight number 3 down here. So interactivity is really powerful. More and more customers are using it now, especially in illustrated parts data. So it's a lot easier for the user to identify parts, so forth. Obviously, this is within HTML, but it could quite easily be in XML and linked to the data module as well in your ITM. So let's go back to the slide. Oh, by the way, that was, we have a product called VisX View HTML5, which will view your CGMs within a browser environment without a plugin as well. So we did kind of have to cross that hurdle because a lot of customers still wanted to use their CGMs, but they couldn't use a plugin like an ActiveX control anymore. So quickly moving on to 3D, there is a chapter within S1000D about 3D data, 3925. From a personal point of view, it's quite high level. It doesn't really go into too much detail, but it's good on giving you some kind of concepts of how you could deliver 3D data within the spec, but it doesn't really give you any kind of granularity around file formats and things like that. So it's mainly about display of the data and where you source the data from. So as we see, there's two major steps in using 3D data in your production environment. One is you gather the data, you source it from your CAD department perhaps, and you would usually want to use perhaps not the whole of the equipment or subset of the equipment like an assembly or sub-assembly, and you want to work with that as quickly as possible. And then we have step 2. Oh, sorry, and with step 1, you would probably then want to create perhaps a 2D illustration of it. So you want to kind of take a snapshot and then create a 2D illustration. And in step 2, you more want to reuse the 3D data as it is in a way that will help your end users. So this could include like things like animation or a 3D parts list. So we're reusing the 3D data in a viewer as opposed to 2D. one of the recommendations they say within the spec is that you actually do this from 3D source data, like engineering data, not generating your own 3D content. And I think that's really down to kind of validation and verification of that data within the spec. So usually the authoritative information will come from the CAD department rather than somebody generating their own 3D data. So they do outline a technical solution, but it's really very open what you can do. So there's no 3D format recommended, either for data interchange or for data display. I think the solution that you choose, they do say that you should actually document it within your business rules. So as long as you document it, then you should be good. The only downside of that is it kind of goes against the spec, because you could pretty much use anything as long as you document it, which could lead to the introduction of proprietary file formats and solutions, which wouldn't be really in the spirit of the spec and probably not good for the project itself. And also could lead to the delivery of multitude of authoring and viewing environments. So I would say our guidance is, at a minimum, select an open 3D file format for your data exchange and display. Data exchange is pretty done, but display is a bit more open. So with step one, we're really using step and IGES. That would be our main kind of open formats. You could use kind of native formats to the CAD system, but I would say the main ones would be step, and mainly step nowadays would be your main format to bring in data to reuse in a technical publications environment. So how would we do that? So I've imported this is our software Visets Edit 3D. I've imported a step file. This is an engine, so it's the whole of the engine. And we can see the breakdown of the engine over on this side. So this is kind of our BOM, our bill of materials, or our model tree. And I might want to start working with this to create an illustration from it. So what we try to do in here is make that as easy as possible, and really stick with the illustration rules that we're familiar with, which would be kind of isometric. We want to go through the different views of the isometric till we choose the right one. We can also work with this freely as well, so we can spin it to any angle that we want, but we're more interested in probably keeping these standard views which we're familiar with. It's also probably unusual that we would work with the whole model. So if I just click on one particular part here, I can see that that is part of the turbo. So I might just want to select the turbo and isolate that and work with that individually. And again, the same applies here. I can just spin it around, move it to perhaps the view that I want, and then begin to work with this model. So obviously that it really works really quickly with the model. Obviously, the bigger the model, obviously the probably more powerful computer I might need. But this is a reasonable size model I'm working with. We've really done a lot of work optimizing it. If I'm doing a spare parts illustration, I probably want to explode it. So I can do this kind of just automatically, or I could work with this just individually. So I can pull parts away manually. That one did stay down, so I can just drag that away. This one I can, sorry, wrong one. This one I can drag up, out of the way. So I'm just working with the parts and dragging them away, and hopefully come into something where I could use it to create our 2D illustration. So I'm not going to spend too much time on this. Okay, you get the idea, hopefully. So now I'm going to export this. And you'll see that I have the option to choose the CGM format. I'm going to click OK or save. In fact, we'll call it a different name. So let me skip it so I can find it. We'll call it S1000D. Okay, so I'm going to create the CGM for this. So there's some settings up here. I would usually just use those them as default and click OK. So what it's going to do is a hidden line removal, and then create me a 2D illustration that I could use in my publication. So it will save it to that directory. The time it takes usually would be based on, obviously, again, the size of the model that you're doing, and how complex it is. So if I go back to Vizex Edit now, hopefully I can open that if I can remember where it is. So let's go back to my desktop. It's actually there. So that's the illustration that we just created. So we've gone from 3D to 2D, and we're in isometric. So, and then we can add our annotations, get our line weights, get it into the right size and so forth. So we've gone really quickly there, and hopefully we're going to finish it with a S1000D compliant illustration. So that's the first scenario. The second one is step 2, where we'd reuse the 3D data as, itself. So with this, it's kind of a bit more open, as we said at the beginning. There is a chapter on it if you want to read that, but as I said, it's quite high level. So it does describe some of the main concepts of delivering 3D data, how it should be used. It should be used when it benefits the end user rather than just arbitrarily. So it might describe complex procedures. It should still contain things like warnings and cautions when parts are removed. So kind of you still got to kind of bear in mind that this is going to be used in the field, and therefore needs to have the same kind of rigor behind it that a 2D would. So what we've tried to do with some of our software is comply to these things, so kind of forward-looking. So things like text should be billboarded, which means it shouldn't rotate with the model. So it shouldn't kind of disappear and then come back and it's in reverse and things like that. It should be called billboarded. We should still be able to have things where we could remove them in an animation mode if we're doing a procedural type data module. And as I said, there should be warnings and cautions still if they're applicable. With color, they're saying to try and use the same palette for S1000D. I don't think this is for the objects themselves. It's more rather than for warnings and cautions and things like that, where you would apply the color. So I'm not going to read all this out, but this is kind of a brief on the spec itself. And then viewing the objects or viewing the model, what the general viewer should have capability-wise, viewing it in isometric and top, front and back, front elevation, so forth. So kind of various guidelines. It should be able to be viewed in isometric still, even though it's 3D. And what we've done is try and develop around these guidelines. So the one thing I did say that was missing is there's no real directive on what format we should choose to deliver, display or deliver to the customer in a 3D format. That could be put into the business rules. But we really, as a developer, needed to choose a format that we thought was, one, open, and the other is that it had a future and it could be sustained easily. And we looked at various formats. Kind of the top X3D would seem the more logical one because it's an XML-based format. but in some ways that's a disadvantage because the file sizes were very large and not easy to handle. So we actually finished up choosing GLTF. And the reason being is that it's an open format, as I said. It's a lightweight format. It doesn't need a plugin on the web to view the 3D graphic. It's really efficient at loading the 3D scenes, and also supports animation. And it really optimizes the 3D file size. So you could view it on a tablet or whatever device you've got. And the other thing is that it's actually supported very well by Microsoft and Adobe, who are part of the group that managed the spec itself. So that was one of the other factors that we looked at. So this is the final demo. The first time I'm going to go to is probably strangely PowerPoint. So I did mention that Microsoft support the format. So this is a GLB file or GLTF file within PowerPoint. So you can see I can insert this into a PowerPoint presentation, or into Word, or into Excel, or they even have within Windows their own viewer that you can view GLTF or GLB files. So all I did was actually insert from my computer. I can choose that particular file format to insert into here. Okay, so that is GLTF. Let me just, so my mouse is not moving. There we go. Let me just find my next presentation. Not sure what's going on with my mouse. Let me just figure this out. Okay, interesting. Okay, I'm back. So the next thing I wanted to show you is that billboarding thing that we spoke about. So now we're in a viewer, again, another viewer within Chrome. And one of the things mentioned was billboarding. So we've created a 3D viewing technology that supports that, and also annotations. So things that you would be familiar with within a normal technical illustration, we've tried to replicate within a 3D viewing environment. So you can see it's definitely 3D. And these things do kind of billboard, so you can still read the text. The other thing it mentioned was views. So we could have isometric views, orthographic views of this, and all this is customizable within our viewing environment. Okay, I'm going to go back to Let's edit 3D. So if we wanted to create these files, then we need an authoring environment. And the last thing we did, last event we did, we spoke about animation, and perhaps having animation within our software and using that perhaps within procedural data modules. And we've now added that function in. So I'm not going to spend, this isn't a demo of the software, but just to quickly show this, to show you the last example. So I've just gone into that mode. I've got my part. So this is similar to what I was doing before with the explosion, but this time I'm going to record that explosion. So if I pull that part away, you can see it's added to the timeline down here. And the same applies, and apply that. And then the same would apply up here. I can pull that away. So now I've created an animation. So we've been working on this to try and make it as easy as possible for illustrators or writers to create these little animations, so they could perhaps use them within a procedure, within technical documentation. So this is 3D, and we now can create quickly animations. So if I want to pull this part away, I just go back, and that will add it to the timeline. The time can be extended out, so I can extend this out down the timeline or move it So once I've applied it, I can move it, so I can move that further down or stretch out. So it could pause or whatever. So we've added a lot of functionality in here. Like I say, I don't want to demo this today, but just quickly show you some of the functions. Like we can rotate this. If it's a gear wheel, we could rotate it. We've had a camera function, so you can capture a camera movement. So if you want to see the other side of it, we could fade parts out. So if you want them to disappear, you could fade the part away so it disappears from the model, and then it's less cluttered. And the final one is color. So say you had a use case where you had a control panel, and you press the button and it changed color, then we could now animate the color change on there as well. So I just wanted to show that we have now that functionality, and it's really easy for you to create these 3D kind of animations. But how are you going to use them? That's the key. So a quick example now with the 3D viewer I just showed you before is that you could have, in theory, a 3D parts illustration. So as I move over the part, it's highlighting the parts list. We could have different views of this. Oh, sub-assemblies, and that will automatically update the parts list. And this is 3D. You can see the speed of the GLB file. It's just really, really fast. And this will work on an iPad or whatever as well. And again, I can change that to update to another. And again, this changes to update. So that's one way we could use it. If we had an animation, then I'm just going to change this background color. Okay, this is our kind of full toolbox. Just this time you could use symbols rather than our own, so you could have your own different logos and so forth, or icons. But this is more of a procedural thing where you would step, and you can step through the procedure with the text. So again, this could be the XML. So this is how you would link your animation to your text to create a procedure. If I go out of sequence, it will give me a little message to say you haven't played it all yet, and then so just to show it is 3D. So the animation features now there, and I think this will be really useful for delivering to the customer. If you have a, like say, a complex procedure, or you need to see behind here to see what's behind it, don't want to hurt yourself, and we could add annotations, warnings, and cautions to this as well. Okay, let's go back. So that's the final demo. As I said, with 3D, there's nothing really very concrete in the spec for the delivery of 3D data, but what we've tried to do is pick out what we think is important and put it in there. And I think once we've kind of validated and accredited and SVG, then I think then start looking at 3D and perhaps doing the similar task there as well. So hopefully you can see we're very focused on S1000D. We want to help people obviously comply and develop kind of the associated software for the graphics, like VisX Edit, which you've seen today, VisX Edit 3D, and VisX View 3D, which was the final thing I was showing then. It's actually a software development kit, so not for everybody, but mainly for kind of vendors that might want to put it into their IETM. But you could use it anyway, perhaps internally if you wanted to. We're going to continue contributing next year to the working group. We'll obviously be attending events, the user forum in 2023, and really want to help people with the solution, but also with the spec as well, where we can. Okay, thanks for your attention. Quite a long webinar, so hopefully you found it interesting. We've got some time for some questions, and hopefully can answer them. Donna, do you want to rejoin us?
Yes, I'm here.
Okay,
Ready?
thank you. I have a question about the actual presentation itself. Yeah, that will be made available. You should receive an email tomorrow. We've also recorded this presentation, so if you want to pass it on to any colleagues, you can do. It'll be on our YouTube channel tomorrow, so you can. You probably won't want to watch it again tomorrow, but it will be there if you want to watch a particular segment. So yeah, and also the slides will be available probably via LinkedIn, our LinkedIn page, and there'll be a link to that on the email that goes out. What are the main differences between Web CGM and S1000D client CGM? Do you want to take that, Don?
Yeah, the short answer is very little. S1000D CGM profile is based on Web CGM. Web CGM was developed in the W3C context to be a general standard, and S1000D adopted Web CGM as the basis of it. So really, the short answer is there's no difference, although it gets labeled, like when we create CGMs in our editor, they get labeled as S1000D, but in fact, it's the basis of it is the Web CGM standard.
Okay, yeah. So you're basically compliant with Web CGM. Will give you a compliant CGM file.
Yes, right.
Okay. Yeah, and also the program itself would in the project business rules would usually outline what it's looking for as well. But we at the moment we have a lot of customers who still create CGMs but then save them as SVGs for displaying their IETM. So from a project point of view, they might not actually deliver them if they're delivering to a customer the SVGs. But they would still possibly deliver the CGMs, but the SVGs would be used purely for display purposes, and that's again down to this plugin technology thing. So please, if you've got any more questions, please ask them. Around 3D, it's kind of a grey area at the moment. We've had to kind of choose a format which we felt was could possibly get selected if there was one selected. So that's the way that we've gone. We're not kind of prescribing it, but there is no real. There's nothing in the spec to say what you should or shouldn't use. So as long as you document what you're using, then that is the main thing at the moment within the spec you're required to do. I'm just reading a question. We have WVRL 3D delivered to us by A350. We'll be able to import and export and edit in the tool. Is that Don? Is that a vermal file? WVRL?
Yeah, I think it's a typo there. I think it's WRL, which is the extension to version 2 VRML files. I think it's
so it's a vermal file.
Yeah, it is. And the answer again there is yes, that's supported both in our authoring tool. You can import them, and then in our viewer too, it will take WRL, VRML files directly. So yeah, so you could bring them in and edit them. Now there is some limitation on what would be translated. For instance, if there was animations in there, there could be some loss of information potentially on animations, but the basic model, 3D model would be imported, exported, so they could be enhanced or updated. So again, yeah, and yeah, so that was a typo. The author of that question responded, yes, a typo. So yeah, good. We're in sync there. So Yeah, that's supported. No problem.
Yeah, and I think it's worth saying that the software that you've seen today, you can evaluate, so we can send you evaluation versions if you want to test any of this out. So visit Edit 3D. If you would like to test it with your files, just request via email, just request an evaluation version. We can send you that. So I'm conscious we've been going for just over an hour, and obviously you probably need to get on with your day. But I'd like to thank you for attending our last or final webinar of 2022. So yeah, thanks for attending. Have a happy Christmas and New Year, and stand by for new videos in the new year. So new videos and webinars, and we hope to see you again then. So thanks for attending, and stay safe. Thank you.